All right, we are now moving into the realm of accelerated motion. So for A, we want to know the acceleration of the object from 0 to 2 seconds. And let's just note one very important fact, which is the slope of the velocity graph is acceleration. So let's just note that. With that in mind, the acceleration from 0 to 2 seconds, let's actually do a rise over run calculation. So I notice that I'm at 2, 2 here, and 0, 0 here. So my rise over my run is going to be 2 minus 0 over 2 minus 0, and that's going to give me 2 centimeters per second squared. I thought I'd use IB notation right there just to get you used to it. Now, is the object moving from 2 to 4 seconds? Well, is the velocity 0? No. So that means, yes, it's moving with a forward velocity of 2 centimeters per second. So it's going forward. Okay. Now, what is the displacement of the object from 0 to 10 seconds? Oh dear. Well, we're going to need to do an area calculation because let's remember from the previous problem, the area of a velocity graph is the displacement. That's the rule. And in fact, I'm going to go ahead and just remind you of that rule one more time right here. So do not forget that fact, young ones. So, in fact, there we go, just to remind you, okay? I'll just leave it here, never mind. Just to remind you, okay? So we're going to use that fact here. So I'm going to split this up. Some of you are smarter than me. I'm going to split this up into a series of different objects. We'll say a triangle, a rectangle, and then another triangle. Okay? Another triangle here, and then a rectangle here. And I'm going to call these regions different things. So this is region 1, 2, 3, 4, and 5. And I'm going to get the area of each region. Okay? And let me just zoom this out just a little bit so that you can kind of see what I'm doing here. Hopefully this works. Ah, perfect. So the area of region 1, it's a triangle, so that's going to be 1/2 base times height, which is going to be 1/2 times 2 times 2, so that's region 1. Region 2 is a rectangle. It's got a width of 2 and a length of 2, so that's going to be length times width, which is 2 times 2. And then for region 3, it's going to be another 1/2 base times height. Okay, so I can just kind of take that idea. So again, 1/2 base times height, which is 1/2, 2 times 2, and then region 4. It's a negative region, so that's negative 1/2 base times height. Actually, I'll just say 1/2 base times height, where it's 1/2 times 2, and it's got a height of negative 2. And then finally, region 5 has an area of negative 2 times 2 because it's a rectangle. And when we add all these up, that's going to be here 2 plus 4 plus 2 plus negative 2 plus negative 4. I'm going to cancel what I can. And I'm getting an area of 2 centimeters. Now, Does the object ever come to rest? Well, let's be clear. Rest means v equals 0. So it's at rest at 0 seconds and at 6 seconds because that's when the velocity is 0. So the answer is yes, at 0 seconds and 6 seconds. Now, does the object ever change direction? So let's be clear. I'm going forward here because I'm speeding up. I'm going forward here at a steady speed. Here I'm still going forward, but I'm slowing down. And right here at 6 seconds, I now start going backwards. So the answer is yes. At 6 seconds, it changes direction. Okay? And finally, we ask, is it possible to determine the initial position of the object from this graph? The answer is no, you cannot. This is a trick question. Okay? It's a trick question. Just so you know. No big deal. All right, so that is question number 3.